All right, everybody. Max's Maximum, a case study on the urinary system. It took the diagnosis of high blood pressure or hypertension at the age of 45 to shock Max into taking better care of himself. A former college football player, he had let himself go, eating too much junk food, drinking too much alcohol, sitting on his chubby bottom for the majority of his last 2 decades, and even indulging in the frequent habit of smoking cigars. Max's physician had to prescribe two different antihypertensive medications or blood pressure lowering medications in order to get his blood pressure under control. She also prescribed regular exercise, a low salt diet, modest alcohol intake, and smoking cessation. Max was scared, really scared. His father had hypertension at a young age as well and ended up on dialysis before dying from complications of kidney failure. Fortunately for Max, he took his doctor's advice and began a dramatic lifestyle change that would bring him to his present day situation. Now, at the age of 55, he was a master triathlon athlete who routinely placed among the top 5 triathletes of the same age group in the country. Just so you know, master means older, not like best of the best. Max's competitive spirit had been ignited by this, but at the same time, he wanted to be first among his peers. To that end, he hired Tracy, a certified clinical exercise specialist, to help him gain the edge he needed to win at the end of the race. His most immediate concern was that he was experiencing problems with dehydration and fatigue because he hadn't found an effective way to drink enough fluids while exercising. Tracy showed Max an impressive array of assessment tools for quantifying and analyzing his physiological state before, during, and after his workouts. One of the tools was urinalysis, which Max found a bit odd, but he dutifully supplied urine samples on a regular prescribed basis. Tracy explained that Max's hydration status was tricky due to the medication he took to control his hypertension, and that renal status, as measured in the urinalysis, was one of the tools she could use to evaluate his physiological state. Before we start to look at the data, just real quickly, hypertension, normal blood pressure is considered 120 over 80. They now have it where really, 140 over 90 is still, hypertension and needs to be dealt with. But really anything between 120 over 80 and 140 over 90, since last year, is now basically like pre-hypertension. So just keep that in mind. I think, high blood pressure is clearly a problem, especially if you look at the kidneys. But so it's good that if someone is 130 over 85, they don't just think, "Whew, I'm not hypertensive." So I'm actually glad they made those changes. So former athletes, so we know that he can, getting back into shape is easier than getting into shape if you've never been there. The two different antihypertensive medications, just so you know, I know one of the questions, talks about ACE inhibitors or angiotensin converting enzyme inhibitors. We won't talk about that. We won't talk about it right now. But most antihypertensives also have mild diuretics, so that could be why she said that his medication is it's tricky to explain his hydration status. So he is probably on, almost guaranteed to be on a mild diuretic, and a diuretic is anything that increases urine production, whether that's caffeine, alcohol, drugs, whatever. Family history of hypertension and his dad needing dialysis. So the connection there is that your kidneys are exquisitely sensitive to blood pressure. So a 20% drop in blood pressure basically makes the kidneys worthless. But if your blood pressure is too high, they seem to be damaged more than any other organ. If you look at it, 80% of people waiting for an organ right now are waiting for a kidney, which seems odd considering that we have two of them. But blood pressure and high blood sugar from diabetes can destroy those tiny blood vessels in kidneys quite easily. All right, so he's a master triathlete. He's very good. He's working with a certified clinical exercise specialist. There, actually, I've gone through that program. It's a very good one, especially if you're looking at people with disease states. They always say, they recommend that you talk to your doctor before starting an exercise program. Well, there are, you're supposed to do things like the PAR-Q to actually, what does that mean? They say go talk to your doctor. What's your doctor supposed to do to know if it's okay for you to exercise? Well, if you're perfectly healthy, you'll pass this PAR-Q test. You can find that on the internet if you want to look at it. But if you have health problems, you should be working with someone that keeps that in mind. If you have really high blood pressure and start lifting weights, that could be a very serious problem. So that's where certified clinical exercise specialists come into play, because especially if you're looking at someone that has underlying disease. But neither here nor there now. All right. Let's go ahead and look. We talked about the medication being an issue. He seemed odd about urinalysis. People think that. People think we have all these high-tech things. Why would I use urinalysis? But it's a very powerful tool. You don't think about what urine is. Urine is filtered blood. So urinalysis allows us to see what is going on in your blood indirectly. So some of my favorite tests are actually urine tests. One of my favorite is what's called the urine organic acids profile. It can tell you about issues with methylation. It can tell you about nutrient deficiencies. It can tell you about genetic things. It is crazy how much you can learn from urine if you know how to look and you know what you're looking for. So don't disregard the urinalysis. It's still a very, very powerful tool. Okay, let's go ahead and look at the numbers now then. Scroll down a bit. So Tracy logs the following results of Max's urinalysis immediately after and 6 hours after a rigorous 2-hour run. So before exercise, urine was pale yellow with a specific gravity of 1.002. Specific gravity basically compares a fluid to distilled water, so water with nothing else in it. So that means that there's more solute in this pale yellow urine than there is in pure distilled water. Protein is absent, glucose is absent, and the pH is 6. So below, 7 is neutral. The pH scale is 0 to 14. Anything below 7 is acidic. This is slightly acidic. So something with a pH of 7 has 10 times more hydrogen ions than something with a pH of 7. Right after he exercises, his urine is dark yellow with a specific gravity of 1.035. Small amount of protein in it. We'll talk about that. No glucose and a pH of 4.5. We'll talk about why that dropped. And then 6 hours after exercise, his urine is yellow with a specific gravity of 1.025. That's actually kind of high for 6 hours after exercise. We'll talk about that. Protein is absent, but now there's some glucose in his urine. So you'll see why the specific gravity of the urine after working out could be high, because there's protein, which functions as a solute there. And why the specific gravity is high 6 hours after exercise, because there's a small amount of glucose, and you'll see the pH there being 5. So we'll go through all this and we'll refer back to it when we need to. Okay, short answer questions. Number 1, what does the color of Max's urine tell Tracy about how concentrated or dilute it is? How does Max's urine color / concentration compare to the urine specific gravity at the same time? Let's scroll back up. Let's cover that second part first. The more pale the urine is, the lower the specific gravity. The darker the urine is, the higher. Remember, specific gravity of 1 would be distilled water. So if his urine had nothing in it but water, it would have a specific gravity of 1. So the fact that it's pale yellow with a specific gravity barely over 1 means there's not a lot in there. That means he's well hydrated and lots of water is passing through him. We have what's called obligatory water loss. We have to get rid of some water because we have to get rid of solutes. So if you're well hydrated, your body will give up extra water. If you're dehydrated, your urine will be very dark yellow, I like to say brown even, but you still have to urinate. I always say that we would pee dust if we could, but we can't. We have to get rid of the toxins and metabolic byproducts that your kidneys are dealing with, so we have to produce urine. So when his urine being pale yellow tells you that he's very well hydrated. I always like to say that kind of straw-colored urine, you don't want it to be too pale yellow or clear, because that could mean that you're overhydrated, which can be a real concern. Obviously, the average American is going to be more likely to be dehydrated than overhydrated, but overhydration in athletes is actually a huge concern. More athletes die, like endurance athletes especially, more of them die from overhydration than they do dehydration. It's pretty crazy, but it's been well studied. I read a book and saw a TED Talk, I think it was called Waterlogged, was the book, and the TED Talk was by the author. His name was Professor Tim Noakes. He's pretty big deal in the sports medicine world. So pale urine, low specific gravity. Dark yellow urine has a high specific gravity. So there's a lot of stuff in here, a lot of solute in this liquid. And it's dark because your body's only putting as much water in as it needs. So the darker your urine, basically your kidneys are saying, I always like to say, just let your kidneys tell you if you're hydrated or not. If you're properly hydrated, your kidneys say, fine, the extra water can pass through, no problem. Your urine is pale yellow. If you're dehydrated, your kidneys will hold on to every drop of water it can, which is why you'll have a dark urine with a high specific gravity. And then we have just regular yellow urine with a 1.025 in the middle. All right, so the darker the urine, the higher the specific gravity. That's the key with question 1. Number 2, based on the urine color and specific gravity, what might Tracy conclude about the hydration status of Max's body at the 3 different times? All right, so number 1, before exercise, he has pale yellow urine with a specific gravity of 1.002. He is very well hydrated. Right after exercises, dark yellow urine with a specific gravity of 1.035. He is dehydrated. 6 hours later, I would still argue that he's dehydrated, or again, other things can affect specific gravity. So I would rather see a pale yellow than full yellow urine, but it's give or take some, right? So he could be properly hydrated here, and we could see the specific gravity number is too high because of another reason, which we'll get into. So, but I would definitely say he's well hydrated before he exercises, he's dehydrated after, and he could probably be better hydrated 6 hours later. Number 3. Antidiuretic hormone, or ADH, regulates the formation of concentrated or dilute urine. In which time period is Max's body secreting its highest amount of ADH? Explain your answer. So antidiuretic hormone is actually produced by neurosecretory cells of the hypothalamus, and then it's stored in the posterior pituitary gland, and its job is to open water channels, which will cause the reabsorption of more water. So if ADH levels are high, you're producing less urine, or at least the urine you are producing is going to be darker and with less water. So he is producing very little ADH when he's well hydrated. So before exercising, with his urine being pale yellow, ADH doesn't have a job to do. After his workout, when his urine is the darkest with the highest specific gravity, that's going to be when ADH is churning out like mad. So why is that? Because his kidneys are telling him, you don't have enough water, so we're going to hold on to all of it we can. We're going to produce just enough urine. So we're going to produce less urine, and it's going to be darker and have more solute in it, per molecule or per water. So ADH levels would be highest right after exercise with the dark yellow urine, and lowest when you had the pale yellow urine. Another just aside here, your kidneys filter like 50 gallons of fluid a day. Without ADH, you'd produce somewhere between 26 or 27 liters of urine a day, which we clearly couldn't do. So ADH is critically important. If you want to see, you want a good example of what happens when you don't have enough of it, alcohol affects ADH. So that's why if you drink 4 beers, you're going to pee out a 6-pack. Alcohol is a powerful diuretic because of its effect on this hormone. So if you've ever broken the seal or just been shocked, you got to pee every 30 minutes when you're drinking. That's what your life would be like if you didn't have enough ADH. Matter of fact, there's a condition, called diabetes insipidus, which that's the problem. They don't produce enough. They don't have enough antidiuretic hormone, so they're constantly producing, just copious amounts of clear urine. The treatment is to give them antidiuretic hormone, or what's called vasopressin. So just so you know, diabetes, when I say diabetes, I'm sure you think, diabetes, type 1, type 2, which is diabetes mellitus. The word diabetes just means to pass through. So a bunch of urine is passing through that person because they don't have enough antidiuretic hormone. So they've broken the seal every day, if you want to use that language. All right, so that's number 3. Number 4, Tracy knows that proteinuria, which is protein in the urine, after intense exercise is physiological, which means normal. If it's a problem, it would be pathological. So, however, protein is typically not present in urine. So why is that? All right, so you have something called the glomerulus, which is going to be a filter, and there are filtration slits in these cells that are overlapping each other. So the glomerulus is designed to only allow water and small things through. So normally, some small proteins probably do sneak through this filter. The first function of the nephron, the functional unit of the kidney, is to filter. And so normally small proteins probably do sneak through, but they're immediately reabsorbed. The next part of the nephron is called the proximal convoluted tubule, and it'll reabsorb those small proteins. So normally large proteins never get through the glomerulus, the filter, and small ones are going to immediately be reabsorbed, so they won't make it to your urine. So there shouldn't be protein in your urine unless, so protein in your urine either means, maybe a very high protein intake, but generally it's a bad sign because it means that there's damage to your kidneys to the point where larger things are sneaking through. Like if you see cells or proteins in your urine, that's generally not a good sign. So why, we're not exactly sure why intense exercise can lead to protein in the urine, but it's quite possible that the filters kind of loosen a little bit, and not saying they're being damaged, but same thing with the blood-brain barrier. The blood-brain barrier is always supposed to be real tight and only allow certain things through, but exercise, and especially fevers, things like fevers can can cause the blood-brain barrier to get a little leaky. So I guess what I would say is to the best of our knowledge at this point, the kidneys just get a little more leaky with intense exercise, and that can lead to protein in the urine. But normally it shouldn't be there, and that's because the filter should keep large things like proteins out. All right, question 5. I think I got that one. Yeah. Question 5. Tracy had been slightly concerned about the trace glucose that was found in Max's urine 6 hours after his exercise until she discovered that he had eaten an entire large pizza an hour before the urinalysis. Explain why glucose might show up in Max's urine after a particularly heavy meal. First, let's talk about what we think when there's glucose in the urine. For normal, healthy people, glucose can be filtered through. I mean, it does very, very easily. Glucose is going to be filtered through the glomerulus, which means one of the, same thing with like vitamins and minerals and all sorts of things. So one of the main jobs of the nephron, the functional unit of the kidney, is to rapidly reabsorb these things. I always say, in class that, we throw the baby out with the bathwater and then we immediately reabsorb the baby. So because for our filters to work, they have to allow small things through. That's good when you're getting rid of small bad things, but that's bad when small good things are getting through. So the proximal convoluted tubule is a very important part of the nephrons of your kidneys. Its job is to reabsorb these things. So glucose would actually be transported back into your blood from this filtrate in the kidneys. So normally a normal healthy person, like I tested my blood sugar today, it's like 78. If you have normal healthy blood sugar levels, all the glucose that's being filtered out is going to be reabsorbed easily. So unless you reach what's known as your threshold maximum or transport maximum, think about these transporters. They're kind of like pumps. They can pump glucose and pump glucose, but if you reach a point where every transporter you have is pumping glucose as fast as it can, and there's still more glucose, it's going to leak through. So imagine like you're pumping water out of a boat that's taking on water. Well, you can only pump so much, and once all your pumps are working as hard as they can, if there's still more water coming in than that, the boat's going to slowly fill with water. So for normal healthy people, the transport maximum, or what's called the renal threshold for glucose, would be 180 milligrams per deciliter. So if somebody has glucose in their urine, you're almost guaranteed their blood sugar is at least 180, which, just so you know, pre-diabetes would be a fasting blood glucose of 100 to 125, and 125 on then would be diabetes with the fasting glucose. So he clearly wasn't fasting. But so why might glucose show up in his urine? Well, so he one of two things. Either he got his blood sugar to 180, which is not good, no matter how big. I mean, no matter how big a meal is, if an hour or two after you eat it, your blood sugar is above like 140 or 150. I would say if you're not pre-diabetic, you're pre-diabetic, like a normal healthy pancreas, and if you have normal amounts of insulin and you're not insulin resistant, your body should be able over the short term to tolerate about anything. So number one is, after eating a massive meal, I mean, there's tons of carbs in there, and glucose in protein, also can cause, insulin levels to change and stuff. So it could be that an hour after eating an entire large pizza, his blood glucose was 180 or higher. That's something I would definitely consider. But number two, he might just have a lower renal threshold. Not everyone's the same. So, I mean, clearly everyone's different. So we generally say, if you look at anything, there could easily be a 30% difference, which would be, that means for some people, glucose would start spilling into the urine at, let's say, 140. And for somebody else, it might not start until you get over to 200, 210, 220. So either he doesn't, his kidneys can't pump glucose as much or as well as the average person's, or his blood sugar really did get that high. So he probably shouldn't eat a large pizza right before urinalysis. So what I would do if I was his doctor is a glucose tolerance test, where pregnant women have to do it, lots of people have to do it, but where you take like 100 grams of glucose in that orange drink, and then they test your blood sugar, but also they could look at your urine. So it'd be neat you need more testing to know what's going on here, but definitely this is a yellow flag, if not a red one. So I would be looking into this. All right, next question. 6. Lactic acid accumulation can be a consequence of intense exercise. Tracy notes that Max's kidneys are working to defend his body against acidosis. How can she tell and describe the mechanism? So first of all, no matter whether it's aerobic or anaerobic exercise, the first step is anaerobic, doesn't need oxygen, and that's glycolysis, where like the name implies, glycolysis rips glucose in half. So the process of glycolysis turns one 6-carbon glucose into two 3-carbon pyruvates. So pyruvate is kind of a cool word. Pyre means to burn, and uva means grape shape. Like your uvula is a grape-shaped structure in the back of your throat. Pyruvate, the word means then burning glucose, which think fermentation. So fermenters turn glucose into pyruvate, but we do as well. But then what happens to pyruvate depends on whether or not we have oxygen. So if Max was just sitting around, then that pyruvate would become acetyl-CoA and would run through your entire metabolic pathway, producing a bunch of energy. But if he's intensely exercising like he does, in an absence of enough oxygen, then some of that pyruvate is going to become lactate or lactic acid, and that can lower your pH and cause muscle failure, etc. But it is an acid, right? So that means intense exercise can lead to lactic acidosis. People have died. People have had serious damage from intense exercise. Now, most causes of lactic acidosis would be like if you see somebody in the ICU or ER with lactic acidosis, it's way more often than not, going to be because of sepsis. So sepsis is, this infection overrunning your body will lower your oxygen levels. So we don't see a lot of people, way more people are septic in the United States than are training so hard that they're almost killing themselves. But so a normal response of exercise, especially the more intense it is there's going to be lactic acid. Well, lactic acid is an acid. So that means your pH is going to drop. So acidosis would be a dangerous drop of pH in your blood. The normal blood pH is 7.35 to 7.45. If the pH dropped below 7.35, you would be in a state of acidosis. If this was actually happening to Max right now, it would be metabolic acidosis because of the lactic acid. It wouldn't be respiratory acidosis because of breathing issues. But so how can she tell that his kidneys are doing their job to keep his pH normal? Well, let's go back up and look. So we don't see his blood pH here, but so we're assuming his blood pH has stayed normal the whole time if she was testing that. But after exercise, his urine pH had dropped to 4.5. So that's because if your body is in danger of going to an acidotic state or becoming acidotic, that means that the pH of your blood is too low. pH is a measure of hydrogen ions. So that means there's too many hydrogen ions in your blood if your pH is dropping. Let's say as he's working out, his blood pH drops from 7.4 to 7.36, whatever. He has all these extra hydrogen ions. Well, the two primary jobs of the kidneys in this situation are they will pour hydrogen ions into your urine. That's why the pH of his urine is dropping. A drop in pH from 6 to 4.5 in his urine is because you're dumping all those extra hydrogen ions into the kidneys. The other thing the kidneys would do is actually produce bicarbonate, which is a buffer. So his kidneys are doing two things. They're getting rid of the extra hydrogen ions, getting rid of the extra acids, and creating a buffer that will help neutralize acids as well. So his blood pH is staying normal because his urine pH is dropping. Remember, urine is filtered blood. So what you're doing is you're filtering out all these extra hydrogen ions that were being produced by exercise. This is great because if you saw a drop in pH in your blood of 1.5 points from 7.4 to what would that be, 5.9, you're dead. So you'd much rather see your pH in your urine go way up or way down than see your blood pH change at all. So that's why we know his kidneys are functioning well. And look, even 6 hours after exercise, the urine pH hasn't recovered. Now, he's not as hydrated as he was. That could be part of it. But there's an oxygen debt that has to be paid after training. He ran hard for 2 hours. So this oxygen debt is not recovered right away. I mean, that's why look at the research that shows that 2, sometimes 3 days later after intense exercise, especially if there's strength training involved, you will see an increase in metabolism. So someone's metabolism hasn't gone back down to normal for days sometimes. So his body is still repaying what's called the oxygen debt, which is why the pH isn't back. But if you give it enough time and you become well hydrated again, you'll see his pH return back to that 6. Okay, so that's the mechanism of how the kidneys would protect himself from acidosis. Number 7, based on Max's urinalysis data, Should he drink more water prior to exercise to ensure that he doesn't dehydrate during intense activity? Explain your answer. The answer is no, and that's because he is actually already well hydrated when he's working out. So, or prior to working out. That's why his urine is pale yellow with a specific gravity barely over 1.002. So if he drank more water before he exercised, he would just fill his bladder and have to pee. It's because right at that point, all the excess water is being moved into his bladder, or at least turned into urine. So what he needs to do is to find a way to get more hydrated during exercise. So do whatever he's been doing to get hydrated before exercise, but find a way to stay hydrated during exercise. Maybe wear a Camelback backpack, drink fluids whenever they're offered on the side of the racetrack, these kind of things. He needs to find a way to hydrate himself during exercise, not after. So let's scroll back up. He does not need this to change at all before exercise. So during exercise, so clearly we're going from pale to dark yellow and specific gravity is going up. So if during exercise he can keep the specific gravity of his urine down by staying more hydrated, by finding a way to do that, and just drinking more while training or while competing, he will hopefully not have the fatigue and dehydration that he's had, and maybe he will end up the number one. What does he do again? Triathlete, yeah, the number one triathlete in his age group. We'll see. Or we won't. He's a fictitious character. So, all right. But yeah, so hopefully understand that he does not need more water before he exercises. He needs it during and then after as well. And he probably shouldn't eat entire pizzas after he trains either. Okay, number 8. This is the last one. Yeah. Number 8. Max's regular exercise regimen has reduced his high blood pressure, allowing him to achieve normal blood pressure on a single antihypertensive medication. Just quickly before I go on, remember he has a family history of blood pressure. The primary cause of high blood pressure is actually unknown. They call it, in up to 90% of cases, they call it primary hypertension, and they don't really know what causes it. So normal 55-year-old triathletes that are top 5 in their age group, et cetera, they probably don't need to be on any blood pressure lowering medication. But you have to understand that with his family history and his dad high blood pressure being very bad, there could be underlying reasons why, even though he's fit and takes good care of himself, he still has high blood pressure. So just keep that in mind. All right, so he's gone from being on 2 antihypertensive medications to 1. The medication he takes is called an angiotensin converting enzyme inhibitor, or ACE inhibitor, which blocks the activation of angiotensin 2. Describe at least 2 mechanisms by which angiotensin 2 targets the kidneys to increase extracellular fluid volume and therefore increase blood pressure. So we have what's called the renin-angiotensin system. And so the goal is for renin to lead to angiotensin 1, which becomes angiotensin 2 when it comes into contact with these ACE enzymes. So the medication he's taking is an angiotensin converting enzyme inhibitor. So his drugs are causing him to produce less angiotensin 2. So let's see why it's a good thing. Other things do that too. Like there was one study showed that pomegranate juice can do that. There are other things that can lower this ACE enzyme level, but obviously the medications are going to be the biggest ones. So what does angiotensin 2 do? Number 1, it's just a vasoconstrictor. It actually, which means it will constrict your blood vessels, and if you're, and that's going to lead to higher blood volume, which would lead to higher blood pressure. That's going to be number 1. It's going to make you thirsty. So angiotensin 2 actually tells your hypothalamus, which is where your body tries to maintain homeostasis, to be thirsty. So not only are you're going to have smaller blood vessels, which means the amount of blood volume you do have would lead to higher pressure. It is also going to tell you to reabsorb more fluid that way, but it's also going to make you thirsty. So if you're drinking more fluid, same thing. You'll have more fluid and your blood pressure will go up. It actually does reduce what's called glomerular filtration rate. So angiotensin 2 does tell the kidneys to stop producing as much urine. It does it directly and also does it indirectly by stimulating aldosterone. Hopefully you remember from your hormones that antidiuretic hormone and aldosterone work really, really closely together. So let's start with ADH. So both the last 2 I'm going to cover here. Angiotensin 2 will actually lead to an increase of ADH and aldosterone. ADH, which we've already covered on here, will open water channels so you reabsorb more water. Aldosterone will cause the reabsorption of more sodium, and then osmosis will have water follow that. So aldosterone and antidiuretic hormone are both leading to more reabsorption of water. Just one's doing it directly, ADH, and one's doing it indirectly, the aldosterone. But both of them are going to lead to more water being reabsorbed from the kidneys, which means less urine is going to be produced. So you'll see several of the mechanisms of what angiotensin 2 does is to decrease urine production. So you're going to decrease urine, just big picture. Angiotensin 2 would decrease urine production, increase thirst, and increase blood pressure in the kidneys. All of those things would raise your blood pressure. So, hopefully you don't have too much of that. And in this case, he needs medication to keep that from happening. Hopefully most people, it's not true anymore, but most humans for most of human history would have been able to maintain normal blood pressure without needing any assistance. It wouldn't have been available for him anyways. So some research looking at traditional hunter-gatherer civilizations estimates that for most of human history, normal blood pressure may have been closer to like 100/60 than even 120/80. But the average human is at least 25 pounds heavier than we used to be. We move a lot less. We eat a diet higher in sodium, and more importantly, actually, we eat a diet much lower in potassium, and those are problems. So, all right, so that's Max, and hopefully that helps you understand how the kidneys work, not only in someone that's exercising, but in the rest of us. So, have a great day.